Welcome. Today our video is on part 3 of general solution of trigonometric equations. So let us take the first problem as if e to the power cos x minus e to the power minus cos x is equal to 4, then value of cos x is options log of 2 plus root 5 base e minus log of 2 plus root 5 base e log of minus 2 plus root 5 and has no value. So clearly there are 4 options and 3 of them are particular values are given, and 4th option is cos x has no value for that equation. So let us take cos x is e to the power cos x is equal to say a, say this become a minus 1 by a is equal to 4, that is a square minus 4a minus 1 is equal to 0. A must have 2 values, but it is not possible to factorize. So a is equal to 4 minus b plus minus root over b square minus 4ac is minus 1. So minus 1 upon is 4, so it is equal a square minus 4a minus 1 is equal to 0. So it is equal to minus b plus minus root over b square minus 4a is 1, c is minus 1 by 2a, so that it is equal to 2 can be cancelled, 2 plus minus root over of 12 divided by, this is plus, this is minus 1, so this is equal to 20, it is 20, 2 cancelled, so 4, 5, that's all. A means e to the power cos x. So cos x is equal to log of number 1 corresponding to plus sign 2 plus root 5 and log of 2 minus root 5 all base e. So value of cos x is either this and that or both, but you see log x, log of 2 plus root 5, 2 plus root 5, it is actually greater than 2, so it is greater than 4. This one is greater than 4. Log 4 base e is greater than 1. So this part is greater than 1. But cos x is greater than 1, it is not possible. And consider the second one. This is 2 minus root 5 within log. Root 5 is greater than 1. So this is negative. So it is not admissible. So this is not admissible, this is also not admissible. So cos x in that equation has no value. So fourth option is correct. Our next problem. Solution set of sin inverse x is greater than cos inverse x is, options are 1 by root 2 comma 1, this closed interval, minus 1 by root 2, 1 by root 2, closed interval, minus half plus half, 0, 1 by root 2. These are the options. So we have to find, this is an inequation. Solution set. Solution set means values of x which satisfies this. We know that sin inverse x plus cos inverse x is pi by 2. So this become greater than pi by 2 minus sin inverse x. Cos inverse x is pi by 2 minus sin inverse x. Or 2 sin inverse x is greater than pi by 2. Sin inverse x is greater than pi by 4. That is, x is greater than sine of pi by 4, which is equal to 1 by root 2. So x must be greater than or 1 by root 2, greater than 1 by root 2. It is greater than or greater than equal to, just 1 minute. Given that, so it is, so x is greater than or equal to 1 by root 2. So only this correct. And what is that? Now we know that values of sin inverse x and cos inverse x also lies between -1 and +1. It is less than or equal to that. So x, it is pi by 2. So actually it is pi by 2. So x actually is less than or equal to 1. Sin inverse x is less than or equal to 1 always. So our x is greater than that and less than 1. So this option is correct. Next problem. General solution of sin 6 theta plus sin 4 theta plus sin 2 theta is equal to 0 are: number 1, n pi by 4 and n pi plus minus pi by 3, number 1. Number 2, n pi by 4 and n pi plus minus pi by 12, 5 pi by 12, sorry, 5 n pi plus n pi by 4 plus 5 pi by 12. Third option is n pi by 4 plus minus 5 pi by 12, and last option is n pi by 4 to n pi plus minus pi by 6. Now our equation is sine 6 theta sine 4 theta plus sine 2 theta is equal to 0. Now simplifying left hand side, it is sine 6 theta plus sine 2 theta plus sine 4 theta is equal to 0. This is of the type sine C plus sine D. 2 sine C plus D by 2 into cos C minus D by 2 theta plus sine 4 theta is equal to 0. That is, taking sine 4 theta common, it is equal to 2 cos 2 theta plus 1 is equal to 0. So it has two factors. Either sine 4 theta is equal to 0, that is sine 4 theta is equal to 0, it gives sine 4 theta is equal to 0, it gives 4 theta is equal to n pi. That is, theta is equal to n pi by 4. Number one, theta is equal to n pi by 4. For second factor, cos 2 theta plus 2 cos 2 theta plus 1 is equal to 0. That is, cos 2 theta is equal to minus half. In fact, it is minus cos 2 theta is minus half, means 2 cos 2 theta pi minus half in second quadrant, it is pi minus negative. Cos 2 theta is negative. In second quadrant, it is pi minus pi by 6. So theta is equal to pi by 2 this. So just 1 minute. Then general solution is 2 theta is equal to n 2n pi plus minus 5 pi by 6. This is simply 5 pi by 6. Therefore, theta is equal to n pi plus minus 5 pi by 12. This one is, so this one is correct option. Now next problem. Number of solution of mod of cos x is equal to sin x in 0 less than or equal to x less than or equal to 4 pi. Now this is a typical type problem. Mod cos x is equal to sin x. We have to solve it. So we can take, there are many ways of them. One is we take x for which cos x is positive. So answer is, solution equation is cos x is equal to sin x, tan x is equal to 1, we can solve. And now take cos x is negative. Negative in where it is negative? In second quadrant and third quadrant, it is negative. So in that case, uh, minus cos x is equal to sin x. That is where now it is pi by 2 pi. It is 3 pi by 2. In that range, the equation is tan x is equal to minus 1. Now we can solve and use this range of x. But it will take time because we have to consider all ranges between 0 to 4 pi where cos x is positive and where cos x is negative. So it will take time. It is very wise to draw the two equations and see where they meet. Like that, suppose this is an equation, this is another equation. They meet at that point. The solution is this. So using that principle, we can solve it using that principle. Actually, we have to draw it. Rough drawing is necessary. Suppose this is 1, this is minus 1, and sin x, it is 0, at pi it is 0, 2 pi 0, 3 pi 0, and 4 pi 0. So it is of the type sorry. This is sin x between 0 to 4 pi. This is sin x, okay. And mod cos x, it will never be negative. It will. At x is equal to 0, mod cos x is 1. So it is there, roughly there. Then at pi by 2, it becomes 0. Then after that, cos x is negative, but as because it is mod cos x, it will be positive. That is, after that, it will rebound back. It will be positive. Where it is again negative, it is pi plus pi by 2. Here negative, in that negative, here also negative. So the rough sketch of that is I produce it by dotted line. Then we see that between 0 to pi by 2, there is a root. Between pi by 2 to pi, another root. So 2 roots, then 3 roots, then 4 roots. It has 4 roots. Options are not given here. Solution is, it has 4 solutions. In this type of problem, drawing rough sketch is very much helpful. Next problem, number of real solution of cos of e to the power x is equal to 3 to the power x plus 3 to the power minus x. Options. Question is number of real solution of this equation. Number of, not where, but number of real solution. Options are 2, 1, infinite, and 0. Actually, this is equal to 3 to the power x by 2 whole square plus 3 to the power minus x by 2 whole square. This is there. I add it minus 2 into 3 to the power x by 2 into 3 to the power minus x by 2. So actually this is no term is there like that, but I have write it. So adjust by 2 because this is 1, this is minus 2, so add plus 2. This gives us 3 to the power x by 2 minus 3 to the power minus x by 2 whole square. Plus, up to that it is this plus 2. So cos of e to the power x we get 2, but it is a cos function. Its value must lie between minus 1 and plus 1. It is greater than 1, so it has no solution. So number of solution is 0. Next. If 1 plus cos x plus cos square x plus cos cube x up to infinite terms is equal to 4 plus 2 root 3, then x is, options are pi by 3, 2 pi by 3, pi by 6, pi by 12. So left hand side is an infinite series in GP, and common ratio of the GP is cos x. Oh, it is given that range of x is given. So value of cos x must lie between 0 and 1, less than 1, greater than 0. So this is infinite GP series, and its common ratio cos x is less than 1. Therefore, its value is this by 1 minus r, that is cos x, is equal to 4 plus 2 root 3. That is 1 minus cos x is equal to 1 by 4 plus 2 root 3. Now multiplying its numerator and denominator by negative of that, that is 4 minus 2 root 3 by 4 in this into that, that is 16 minus 4 into 3, 12, that is 4. This is equal to 4 minus 2 root 3 by 4 is equal to 1 minus root 3 by 2. So we get 1 minus cos x is equal to 1 minus root 3 by 2. That is cos x is equal to root 3 by 2. So x is equal to, and mind that x lies between 0 and pi by 2, x is equal to pi by 6. So this is of correct option. Our next problem. Solution of 3 sine square x minus 12 sine x cos x minus 9 cos x plus 4 sin x minus 9 sin x plus 4 cos x plus 3 cos square x is equal to 0. Just 1 minute. Okay. Minus 12 sin x cos x minus 9 sin x plus 4 cos x plus 3 cos square x is equal to 0, and range of x 0 pi. Question is, number of solution of that in here, how much? Number of solution, options are 1, 2, 3 and 4. Now you see, they together is 3, this and that, plus 4 cos x. From these two, minus 3 sin x can be taken common. So it is 4 cos x, 3 sin x minus, actually minus 3. I think there is one, minus 12 plus 4 cos x plus 3 cos square x minus 9 sin x. Okay, then it is 3, they together is 3 plus 4 cos x, taking minus 3 common, it is 4 cos x plus 3. This is plus 3 is equal to 0. So actually 4 cos x plus 3 can be taken common. 3 plus 4 cos x into 1 minus 3 sin x is equal to 0. We have to find number of solution of this equation in that range. So if this is 0, 1 minus 3 sin x is equal to 0, that is sin x is equal to 1 by 3. How many solutions are there within that range? It is actually sin x is equal to 1 by 3. One root, it has one root in first quadrant and one root in second quadrant. It is, if it is alpha, pi minus alpha is another root. So it has 2 solutions. And if this is 0, then cos x is equal to minus 3 by 4. It is negative. It has one root in second quadrant. Cos is negative in second quadrant. It has no root in first quadrant, only one root in second quadrant. So it has only one root. So total number of solution is 3. So this is correct option. Next. Our next problem is the range of B for which sin square x minus root 3 sin x cos x is equal to 2b minus 1 has a real solution. Sin square x minus root 3 sin x cos x is equal to 2b minus 1 has real solution. What that solution, I mean a range of b, how much? Options are 1 by 4, 5 by 4 within closed interval. First option 1 and 2 closed interval. Third option is greater than or equal to 5 by 4. Fourth option is less than or equal to 3 by 4. So for that is range of B is either this or that, this or that. These are the options. Now this can be written as in terms of sin 2x can be written. This can be written in cos 2x because cos 2x is equal to 1 minus 2 sin square x. That is sin square x is equal to 1 minus cos 2x by 2. So it is equal to 1 minus cos 2x divided by 2 minus this is root 3 by 2. This is 2 and another 2 here. So it is sin 2x is equal to 2b minus 1. So that it can be written in terms of linear combination of sine and cos. 1 minus, okay, sine square, actually 1 minus cos 2x by 2. 1 cos square minus sine square. So this is cos square x minus cos square x cancel, sine square x, okay, minus sine 2x is equal to that. So that it is equal to one, this and that is taken into that side. So half of cos 2x plus root 3 by 2 sine 2x is equal to 2b. No, this is, it is, that is positive there, this is there. So it is equal to half plus 1, 3 by 2 minus 2b. But actually you see it is cos 2x cos, this is half is cos pi by 6. So it is equal to cos of 2x plus pi by 6 because this is sin pi by 6 sin 2x is equal to 3 by 2 minus 2b. But its value must lie between minus 1 and plus 1. So its value also lie between minus 1 and plus 1. From this we get 2b is less than or equal to 5 by 2. That is b is less than or equal to 5 by 4. And from this 2b is greater than or equal to half. That is b is greater than or equal to 1 by 4. So b must lie between 1 by 4 and 5 by 4. So this is the correct option. Now our next problem. The number of possible values of n in general solution of tan pi cos theta is equal to cot of pi sin theta is, options are 1, 2, 3, 4. Acha. Once again, I am repeating the problem. Number of possible values of n. N is not here, but language is number of possible values of n in general solution of that. In general solution, n will be there. How many n are possible? This is the question. It is equal to, this is equal to tan of pi by 2 minus pi sin theta. Therefore, pi cos theta, tan x is equal to tan alpha. So, tan x, if tan x is equal to tan alpha, it is equal to n pi plus pi by 2 minus pi sin theta. Theta can be cancelled. Sorry, pi can be cancelled all along. So sin theta plus cos theta, this sin theta plus that cos theta after cancelling pi is equal to n plus half. That is 2n plus 1 by 2. Now, its solution actually dividing both sides by root over of 1 square plus 1 square, that is by root 2. So 1 by root 2 sin theta plus 1 by root 2 cos theta is equal to 2n plus 1 by 2 root 2. That is sine of theta plus pi by 4 is equal to 2n plus 1 by 2 root 2. You see, this is sine function. So its value must lie between minus 1 and plus 1. If n is equal to 0, then it is 1 by 2 root 2. 1 by 2 root 2. If n is equal to 1, this is possible because it lies between minus 1 and plus 1. So one admissible value is n is equal to 0. Next take n is equal to 1. It is equal to 3 by 2 root 2. 3 by 2 root 2. It is less than 1 because it is greater than 3. So n is equal to 1, another admissible value. If now take n is equal to 2, this is 5 by 2 root 2. 5 by 2 root 2, it is greater than 1. So this is not possible. So n is equal to 2 is not possible, is not admissible rather. No need of taking n is equal to 3, 4, etc. So we get n is equal to 0 and n is equal to 1. Now consider n is equal to negative value, n is equal to minus 1. In that case, it is minus 1 by 2 root 2. It is within the range minus 1 and plus 1. So this is also admissible. Take n is equal to minus 2. So minus 5, it is minus 5 by 2 root 2. It is not admissible. It is less than minus 1. So 3 admissible values of n are there. One is n is equal to 0, other is n is equal to 1, and n is equal to minus 1. So answer is 3. Base. Okay. Thank you for today. Next day we take some other problems. Thank you.